This is Algebra 1, Semester 1. It's the third unit called Graphing Linears. Linear is another name for lines, so graphing lines. It's the third unit called Rate of Change, and that's what a slope is. We'll talk about that in a minute. Oftentimes there's a practice here, so we'll put that on. This is on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the website. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So I do usually try to, before doing the problems, model for you where these notes are. They are hard to find, you guys, so you're going to have to find them once. But once you find them once, you should be able to get back here, all right? So this is the address of the website, creatormath.weebly.com. And if you Google that, you should get to this homepage. All right, under this, if you have any questions about the composition book, please scroll down, find the words composition book, follow all the instructions, watch all the videos, and adhere to the deadlines. Put the right things on the right pages. And you should have a 90 to 100% on your composition book, all right? Here's where the notes are. We're going to go to the tab of the class of the video we're making right now. So under the tab of the class, there should be vocabulary, notes, lesson videos like we're making now, and problem sets or practice sets, right? All four of those will be under this tab here. So if you're not getting 100% on your vocabulary practices, you may not know that there is a PDF of every vocabulary word we will use for the entire school year. It is downloadable to your device. It is searchable. So please Google how do I search a PDF with whatever kind of device you're using. It's a little bit different per device, so you're going to want to follow directions for your device. Next most important thing is to go to the semester that you are in. If you get to the wrong semester, you won't find what you're looking for. This is the table of contents for this semester. All of this table of contents should have been written by you, the student, onto pages 2 through 6 of your composition book. If you haven't done that already, please stop what you're doing now and do it. Watch the prior videos on the composition book if you don't understand how, and hopefully you will understand after that. Now we're going to the unit involved. Here's all the lessons within the unit, but this is the unit, Graphing Linears. We are in number 3 lesson here, Rate of Change. Here are the page numbers on which your notes go in your comp book. Please do not take this video's word for it, but go back and find the original table of contents. At the time you're viewing this, these page numbers probably will have changed. These are the notes, these are the problem sets, and the video solution we're making right now. We'll go here. Sometimes it takes me a couple times to open the notes, but this is talking about rates of change. So here are some examples of rates of change. Miles per hour. It can also be written in a fraction, miles per hour. Feet per second. It can also be written in a fraction, feet per second. A rate of change typically in Algebra 1 is a physical change per time. All right? Miles per hour is we changed so many miles. We went 5 miles in 1 hour, right? That's a physical change, distance, miles per hour. Feet is 2. Kilowatts might be, what's that, energy or electricity? Kilowatts are a measurement of electricity that's flowing per hour. So some physical change in electricity is a physical change that happens per hour. And it's not always a physical change per time, but that's probably the easiest way to remember it and the most common when you're talking about Algebra 1. So other things here, like notice that in a rate of change, the fraction bar is pronounced per. So if you have a fraction, miles per hour, we pronounce that fraction bar per, as in miles per hour. All right, graphing a rate of change is called slope. So this gets back to what we're doing with the standards. We're following slope and rate of change and understanding what rate of change is and its rise over run. 2 miles per hour means we're rising 2 and running 1. All right, so 2 over 1 or 2 miles per hour. Typically in a rate of change, the denominator, hour, will be 1. So if it's 5 miles per 1 hour, rarely will a rate of change be 5 miles per 10 hours, although it could be. Oftentimes we'll simplify it, right? And let's say it's 10 miles per 5 hours, that would be 10 divided by 5 would be 2 miles per hour. We would always try to convert it, if possible, to a singular aspect of an hour in the denominator. That's part of how we use rates of change. All right, so with that, there's vocabulary, rate of change, fraction bar, slope, dynamic. By the way, dynamic means movement. If you have a dynamic motion, right, a dynamic situation, it's moving. If you have a static situation, it is not moving. It is still or steadfast. Okay. So let's see what problems they give us. They often warm us up with some definitions and basic understandings. In general, what's a rate of change? It is a physical change per time. All right. In general, that's a pretty good understanding of it. If you have an understanding of that, you're going to do all right. All right. Which of the following examples are of rates of change? Which of the following are examples of rates of change? More than one answer may apply. So miles per hour, yes. Miles per hour, written a different way, but the same thing. Feet per second, kilowatts per hour, kilowatts. These are all rates of change, you guys. Trick question. They're all the right answer, right? This is not a trick question, but not typical. What is the line between the numerator and the denominator fraction? 1 over 2 is also per. 1 per 2 is also acceptable to say. This is a fraction bar, and we also say it per. Okay, so here's a fraction bar. That's the name of this thing between here. And how do we say it? We say it per. Okay, so if you have 2 per 1, like 2 miles, right, per hour, per 1 hour, we say this fraction bar now as per, right? You can also say divided by, you guys. If we had 1 over 2, we could say 1/2 or 1 divided by 2. Remember 1 divided by 2? Remember that? So also we can say a fraction bar as divided by. And it's interesting how students use these terms, but I don't know if they have ever thought about them sort of specifically just thinking about that issue. In graphing, a rate of change is called a slope and is a rise over run. That's true. In graphing, our rate of change is a slope. 2 miles per hour is a slope of 2 over 1, or a rise of 2 and a run of 1. 2 miles per hour, right? 2 over 1 is a rise of 2, a run of 1. That's exactly what slope is. Rise over run. Okay, so you're trying to link up all these different things you know and you've dealt with in your life and trying to make some heads or tails. And that's what makes this topic so complicated. There's about 10 different ways to examine every topic within it. What does dynamic mean? It means movement. If we have dynamic, we have motion, right? If a human traveled 100 miles in 4 hours in an automobile, what is the rate of change? Well, it's 100 miles per 4 hours, right? What's 4 divided by 100 is 25, and what we'll typically write now is miles, and we'll drop in the word per hour because the 4 becomes 1 on the bottom, right? And this line, fraction bar, means per. That's how we say it. So 100 miles per 4 hours will become 25, simplified to 25 miles per 1 hour. So here it is here. 100 miles divided by 4 hours is 25 miles per hour. That's pretty straightforward. They're mapping it out for us even. All right, a bird flew 100 miles in 10 hours, so just write it out. 100 miles per 10 hours. The 10 goes into here 10 times, so we're left with 10 miles per hour. MPH, right? 10 miles per hour. All right, a cheetah ran 60 miles in an hour, right? So it's 1 hour. So we can literally just write 60 mph, right? Miles per hour. It's only 1 here. We don't have to do any simplifying or anything. So 60 miles per hour. And I think that's what they say a cheetah can run over short distances. They're very fast. What is the rate of change? I think it's the fastest land animal, to be honest, with my limited lack of knowledge, but I think that's what it is. What is the rate of change of the following graph? Okay, so rate of change is slope. Slope is rise over run. How much does this line rise this way? We rise 1 and we run 2. So I like 1 over 2 or 1/2. So a slope, rise over run, is a rate of change just exemplified on a graphic image called a graph. And this is a Cartesian coordinate system with an x-axis and a y-axis, just like all the old days you've been working with for many years. It doesn't change. The x-axis always stays horizontal and the y-axis always stays vertical. What is the rate of change of the following graph? All right, rate of change, so slope is rise over run, right? That's what a rate of change is on a graph. Rise over run. All right, let's start here. If we rise 1, how far do we run? We have to run, but we're running to the left, so it's got to be -1. So 1 over -1 is negative. 1 over 1 is -1. Aww. What's the rate of change of the graph? So it's going to be slope. Slope equals rise over run. I'd write it out each time until it's really clear to you. Okay? Rising 1, 2, and we're running 1. So 2 over 1, which equals 2. What is the rate of change of the following graph? Well, this one's going to be negative because it's up to the left. We already learned about positive and negative graphs. This is going to rise 1, 2, 3. So we're rising 3. So slope equals rise over run, which equals 3 over, we had to go to the left though, so -1. This equals -3. For the following graph line, between 0 and 3, is the rate of change positive or negative? So here's 3 and 0, okay? This is going up to the right, so this is a positive rate of change. This is flat, so it is 0 rate of change or no slope. This is down to the right, right? This is a negative slope or rate of change. So the graph line, they want just this one, and it's positive. The graph line goes up from left to right and therefore has a positive rate of change. All right, this part, the slope or rate of change, is positive here. Now they're going to ask about the next part. Between 3 and 6, which is this one. This one, the graph line goes from left to right, has a negative. Let's see, the graph line goes down. Nope. The graph line goes up. Nope. Here, I like this one. Get rid of this. The graph line does not go up or down from left to right and therefore has a 0 rate of change between 3 and 6. Okay, that's what they're asking for right here and here. And it looks like this doesn't line up perfectly. I'd like it if this lined up right there perfectly. I might go back and look at this, and I might go back and look at this, okay? So, but it does not, this is a 0 rate of change. It is neither up nor down. It is flat on the graph. For the following, let's see, for the following graph line between 6 and 9, okay, here, it's a negative because we're headed down. It is, graph line does not go up or down. These are backwards. So the graph line from left to right, let's see, goes down. Here we go, this one. The graph line goes down from left to right and therefore has a negative rate of change. Okay. That's what rate of change is, and it's slope when you're talking about graph lines. So we use slope and rate of change interchangeably pretty much as we're talking about different things. Miles per hour if we're going up, right, that would be an increasing rate of change. And if miles per hour were decreasing, then it would be a negative rate of change. So make sure you're matching up the title of this video with the title of the practice set you're doing. Otherwise, it won't make much sense, and hope that helps.